Electrical code considerations are vital for safety in areas like aircraft hangars and engine rebuild shops. The National Electrical Code, specifically Article 525, applies to commercial garages where gasoline-powered vehicles are serviced. Some requirements include GFCI protection. All 125-volt, 15-amp and 20-amp single-phase receptacles located within 1.8 meters, which is about 6 feet, of the floor must be GFCI protected. Also, electrical wiring exposed to damage must be installed in conduit or flexible raceways. NEC Article 406.8 specifies general requirements for aircraft hangars, including adequate ventilation to prevent accumulation of ignitable vapors. Electrical equipment and wiring must be installed in accordance with Article 525 or Article 500 of the NEC, which covers hazardous locations. Based on the information provided, an engine rebuild area in a hangar would likely be classified as a commercial garage under NEC Article 525 due to the work being performed on gasoline-powered engines. Therefore, specific requirements must be met. All receptacles in the rebuilt area should be GFCI protected, and Romex wiring should be sleeved in conduit or flexible raceways to protect it from damage. Recommendations include installing GFCI protection, ensuring that all receptacles in the engine rebuild area are GFCI protected. Sleeve the existing Romex wiring in conduit or flexible raceways to comply with NEC requirements. Depending on the specific materials used in the engine rebuild area, such as flammable liquids or solvents, additional requirements under NEC Article 500 may need to be considered. It is advisable to consult with a qualified electrician to ensure that all electrical installations and modifications meet the applicable NEC requirements and provide a safe environment for workers. In more detail, let's examine some of these critical electrical code aspects. The National Electrical Code, or NEC, is a comprehensive set of standards designed to ensure the safe installation and maintenance of electrical systems. It's not just a suggestion, it's the law in many jurisdictions, and adhering to it is crucial for preventing electrical hazards. Article 525 of the NEC specifically addresses hazardous, classified locations. These are areas where flammable gases, vapors, or dusts are present, or may be present, creating a risk of fire or explosion. In an aircraft hangar, especially where engine rebuilding is taking place, these hazards can arise from fuel, solvents, and other flammable substances. When an area is classified as hazardous, it triggers a host of additional requirements. Electrical equipment used in these locations must be specifically designed and rated for such environments. This includes explosion-proof enclosures, intrinsically safe circuits, and other measures to prevent ignition. Wiring methods must also be carefully selected to minimize the risk of sparks or arcs. Proper ventilation is another key consideration in hazardous locations. The goal is to prevent the accumulation of flammable vapors or gases by ensuring adequate air circulation. This may involve installing exhaust fans, ventilation systems, or other measures to maintain a safe atmosphere. Now let's talk about GFCI protection. GFCI stands for Ground Fault Circuit Interrupter. These devices are designed to protect people from electrical shock by quickly interrupting a circuit when a ground fault is detected. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are incredibly sensitive, tripping at very low current levels, typically around 5 milliamps, which is far below the level that can cause serious injury or death. In areas where there is a higher risk of electrical shock, such as wet locations or those where electrical equipment is used near grounded surfaces, GFCI protection is essential. The NEC mandates GFCI protection for receptacles in various locations, including bathrooms, kitchens, outdoor areas, and construction sites. In the context of an aircraft hangar or engine rebuild area, GFCI protection is particularly important due to the presence of conductive materials, such as metal aircraft components and tools, as well as the potential for damp or wet conditions. All 125-volt, 15-amp and 20-amp receptacles within 6 feet of the floor should be GFCI protected. This helps to minimize the risk of electrical shock to personnel working in the area. Moving on to wiring methods, the NEC specifies requirements for how electrical wiring should be installed to ensure safety and prevent damage. One common wiring method is Romex, which is a type of non-metallic sheathed cable. While Romex is suitable for many applications, it is not typically permitted in areas where it is exposed to physical damage. In an aircraft hangar or engine rebuild area where tools, equipment, and aircraft components are constantly being moved around, Romex wiring could be easily damaged, creating a safety hazard. Therefore, the NEC requires that wiring in these areas be protected by conduit or flexible raceways. Conduit is a rigid metal or plastic tubing that provides a physical barrier to protect wiring from damage. Flexible raceways, such as flexible metal conduit or liquid-type flexible metal conduit, offer similar protection while also allowing for movement and flexibility. By encasing wiring in conduit or flexible raceways, the risk of damage from impact, abrasion, or other hazards is greatly reduced. This helps to ensure the long-term reliability and safety of the electrical system. In addition to these specific requirements, it's also important to consider general electrical safety practices. This includes proper grounding of electrical equipment, regular inspections of electrical systems, and the use of appropriately rated electrical components. Overloaded circuits, damaged cords, and improper wiring can all create safety hazards. It's also crucial to ensure that all electrical work is performed by qualified electricians who are familiar with the NEC and other applicable codes and standards. Regular training and education can help to keep personnel up to date on the latest safety practices and procedures. Now let's delve into NEC Article 500, which addresses hazardous locations. These are areas where flammable gases, vapors, or dusts are present, or may be present in sufficient quantities to create a risk of fire or explosion. Article 500 divides hazardous locations into different classes, divisions, and groups, depending on the type of hazard and the likelihood of its presence. Class I locations involve flammable gases or vapors, Class Roman II locations involve combustible dusts, and Class Roman III locations involve ignitable fibers or flyings. Within each class, there are divisions that further categorize the hazard based on the probability of its presence. Division 1 locations are those where the hazard is normally present, while Division 2 locations are those where the hazard is only present under abnormal conditions. The NEC specifies different requirements for electrical equipment and wiring depending on the class, division, and group of the hazardous location. Equipment used in these locations must be specifically designed and rated for the particular hazard. This includes explosion-proof enclosures, intrinsically safe circuits, and other measures to prevent ignition. Wiring methods must also be carefully selected to minimize the risk of sparks or arcs. In an aircraft hangar or engine rebuild area, the presence of fuel, solvents, and other flammable substances may necessitate classifying certain areas as hazardous locations. This would trigger the additional requirements of Article 500. It's important to conduct a thorough hazard assessment to determine the appropriate classification for each area. This assessment should take into account the types of materials used, the ventilation in the area, and the frequency and duration of potential releases. Once the hazardous locations have been identified and classified, the appropriate electrical equipment and wiring methods can be selected. It's also important to implement procedures to minimize the risk of ignition, such as controlling sources of ignition and ensuring proper ventilation. Regular inspections and maintenance of electrical equipment are also crucial to ensure its continued safe operation. It's also advisable to consult with a qualified electrical engineer or specialist in hazardous locations to ensure compliance with the NEC and other applicable codes and standards. Now consider the importance of consulting with a qualified electrician. Electrical work can be dangerous, and it's not something that should be attempted by untrained individuals. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC and other applicable codes and standards. They can assess the electrical system, identify potential hazards, and recommend appropriate solutions. They can also install, maintain, and repair electrical equipment and wiring. When hiring an electrician, it's important to check their credentials and ensure that they are licensed and insured. A licensed electrician has met the requirements for education, training, and experience established by the licensing authority. They have also passed an examination to demonstrate their knowledge of electrical codes and standards. Insurance protects both the electrician and the property owner in case of accidents or damage. It's also a good idea to ask for references from previous clients and check online reviews. A reputable electrician will be happy to provide references and answer any questions you may have. When discussing the scope of work with the electrician, be sure to provide as much detail as possible. Explain the problem you are experiencing, the desired outcome, and any specific requirements you may have. The electrician can then provide you with a detailed estimate of the cost and time required to complete the work. It's also important to obtain a written contract that outlines the scope of work, the payment terms, and any warranties or guarantees. Before the electrician begins work, be sure to review the contract carefully and ask any questions you may have. During the work, it's important to stay informed about the progress and any changes that may be necessary. The electrician should keep you updated on the status of the work and explain any issues that arise. It's also a good idea to ask the electrician to show you the completed work and explain how it functions. After the work is completed, be sure to obtain a copy of any permits or inspections that were required. These documents demonstrate that the work was performed in accordance with applicable codes and standards. Finally, it's important to keep records of all electrical work performed on your property. This information can be useful for future maintenance, repairs, or renovations. In summary, ensuring electrical safety in aircraft hangars and engine rebuild areas requires careful attention to detail and adherence to the National Electrical Code. By understanding the requirements of Article 525, Article 406.8, and Article 500, implementing GFCI protection, using appropriate wiring methods, and consulting with qualified electricians, you can create a safe and reliable electrical system. Remember, electrical safety is not just a matter of compliance, it's a matter of protecting lives and property.